Over to you, Paul.
Okay. Greetings, everybody. This is Paul Hardy calling from Sydney, Australia. A little bit later than advertised due to unforeseen technical problems, but all fixed now, so we're good to go. What I'd like to talk to you about this fine day is the theory and reality of transforming old-fashioned monolithic code, known as legacy code, into modern OO things based on reality. Before we get going, I would just like to draw your attention to something. I've got a competition going on. So during the presentation, you've got to watch out for the Eggman. This is what he looks like. He'll pop up 3 times during the presentation. I won't mention him. He'll just be there, hiding on a slide. And each time, he'll have a word on his placard. There are 3 words in total, so make a note of them. And then at the end, go into the blog that's indicated there, the Rocking All Over the SAP World blog, and put the 3-word phrase in the comments, and the very first person who does will win a prize. So that's making it a little bit more interesting. And let's get going. The basic premise of this whole presentation is that the vast majority of current ABAP code is what's known as legacy code. It can be changed into something a lot better with minimal risk. I've done it for real. The agenda will be, you'll hear about my company for about 2 seconds, because no one's really interested. The problem I'm trying to address, the theory behind fixing that problem, and the reality behind fixing that problem. Okay, I work for a German company called Heidelberg Cement, which is based in Heidelberg and makes cement and other building products. Now, you don't really care about that, but what you do care about is the similarities. Just like your organization, we run SAP. Just like 99% of organizations, we've got 500 million tons of Z code in the system. And just like your organization, we want to stay with SAP, so eventually we're going to have to move to S/4HANA, which necessitates having a slightly more modern code base than we actually do. So what is the problem? The problem is legacy code. What in the world is legacy code? You ask 10 different people, you'll get 10 different answers. Tell you what it isn't. Legacy code is not the code you had in a system before you had SAP. People refer to those as legacy systems, hence the confusion. But no, you don't use that code anymore. We use SAP code. So legacy code cannot be from the old system. Is it procedural programming? Not in the slightest. In fact, it's more than possible to write good code procedurally and legacy code using object orientation. So it's not that. The actual definition that I'm going to be using today is one from Michael Feathers, the American author, who says that legacy code is quite simply code without tests. Code without automated unit tests. Why? Why is that a bad thing? There's 3 reasons, at least. First off, these gigantic monolithic programs tend to be business critical. Your organization cannot live without them. And that means you've got to keep changing them. And when you change them, you change one area, it's 99% likely it breaks the code in another area. Happens all the time. Thirdly, if it's really convoluted, appearing to have no structure, you're really, really scared to, I don't know, remove bits that don't seem to do anything or make any sort of change because look at something, wonder what that does. Looks like it does nothing, but I'll keep it there just in case. So you end up with a lot of useless rubbish in your system, let's put it that way. But it doesn't have to be this way. You don't have to be terrified to make changes, and hence not make them. There is a solution. Let's talk about a theory to start off with before moving on to what I've done in real life. The most important book on this subject was written quite a long time ago in IT terms, and that old Working Effectively with Legacy Code by Michael Feathers. What he wanted to do was ensure you could make changes to any sort of code without tests in a safe manner, trying to reduce the risk down to zero. The problem was that book, all the examples were in Java. So most ABAP people took one look at it and said, that's no relevance to me whatsoever, because I don't program in Java. I program in ABAP. So they put the book down again, don't consider it ever. Some years ago, I was contacted by a consultant saying a bank had 3 ERP systems all chock full of legacy code, and they were looking at hiring Michael Feathers in order to give them a workshop, talks, all about, I've got a 2-year-old banging on my door, all about how to work with their legacy code, of course. The problem was one of those 3 ERP systems was SAP, and Michael Feathers had pretty much zero experience with SAP and the ABAP language, or I never even heard of it. More people are unaware of ABAP than you might think, despite big companies using it. So anyway, they called on me to try and transform his theories and his examples into an ABAP context. I thought, great, sounded good to me. It would look great on my CV, but alas alack, never came to anything. Bank got cold feet, decided things were fine the way they were. Oh well, never mind. The work I did then wasn't wasted because I'd worked out how to apply those principles in ABAP. His theories basically start with the requirement you have. And obviously you've got to work out what to change. You might have 20 million requirements, but of course you do them one tiny bit at a time. Then you've got to work out, what is it I'm actually going to change? You might find you have to make the same change in about 20 different places in your code. If so, that's a clear indication you've got duplicated code, which needs to be extracted into its own method or subroutine of some form. Hence, this is the don't repeat yourself principle. In Eclipse, that's quite easy to do, by the way. It's got an extract function where you highlight some code and just press a magic button and it puts it into its own method. And that's great. So you found the actual lines of code that you want to change. So far, so good. The next point is finding a so-called inflection point. What in the world is one of those? Technically, it's a bit on a roller coaster ride where you're moving across on a flat bit before you suddenly go up or down very dramatically. In programming terms, what that means is it's a piece of code which is going to change something else that calls it. And you start from your line of code, see what routine it's in, do the where used list. And as soon as you find that that routine is used by 2 or more things, that's your inflection point. Why do you want to find such an obscure thing? It's because you're going to write a test for it. You're going to write a test for the routine that's called by more than one thing. If it's a function module, it could be called by loads and loads of things, or a global method. Then you look at what your inflection point is supposed to be doing. At this point, it doesn't matter if it's doing anything sensible or not. You just got to say, what does it do now? And take that as correct behavior, even if you're going to change it in a minute. Because you're going to write a test. You're going to write a test that proves it does what it's currently doing. This is what Michael Feathers calls a vise in USA speak, or a vice in England, where you put the code into a harness, make a change, and make sure it keeps doing the same thing. So put the test in first before making any changes. That way you'll know when you've changed it. The problem is that most code in legacy code systems is impossible to test, impossible to write a test for. And why would that be? That would be because code is full of dependencies. In Michael Feathers' books, he talks about object-oriented code virtually all the time. It's got what's called external dependencies, where objects are passed in, and internal dependencies, where a class creates objects itself. These have to be changed to parameters or factory methods. But that's pretty irrelevant to most people, because most people's code is wholly procedural. Now that has got even more dependencies, because we keep doing things like running off the database to get data, customizing data or transactional data. You keep popping up dialog boxes to the user to say, like, are you sure? You can print things or interface with an external system. All of that makes testing impossible, because you need a real user to say yes or no, or a real database full of data, or a real printer, and so on, so on. The idea is to abstract every one of those dependencies into its own class. A class which solely does database reads, a class which solely prints, a class which solely asks the user questions. Then, during a test, that class can get created by a factory, and that factory gets what's known as injected with a fake or a mock, or whatever they want to call it. A test double is the technical term, where it looks like the database class, but it gives you back false hard-coded values. So all that's being tested is the business logic. At that point, you've got the building blocks in place to try and actually start making the change. And this is where test-driven development comes into the equation. Oddly enough, it's hardly ever mentioned in the Michael Feathers book. There's a page on it, which is referenced a lot. It's not mentioned very much. But in fact, it's the whole crux of the matter. This is the important thing. And it's a strange way of programming to traditional ABAP, because you write the test first before making your change or adding something new. You write the test and it fails. Of course it does. You haven't made the change yet. So of course it's going to fail. That's good. That's what we want. That's called the red phase. If you don't have a failing test, you'll never know when you're finished. Then, once you've got the test that fails, then you actually do make your change. Write some new code, change some existing code, or what have you. All well and good, until such time as a test passes. Then you know you're finished. Lovely. The third step, once it works, you can making it better. The phrase is first make it good. First make it right, sorry. Make it work, then make it good. And the blue phase is making it good. You end up with some code that works and is high quality. They're not one and the same, by the way. And you can move on to the next requirement. That's great. That's a wonderful, wonderful theory. But it's only a theory. Let's see if we can turn that theory into reality. Because this is what I've been doing. This is what I've been doing for 1.5 years in Germany. And it's what I'm doing right now in Australia. So how do I go about it? most of all, in both countries, I picked the same candidate program. It was a custom wrapper for VA01 to create sales order transaction. It's obviously got 500,000 extra features added and a much simpler user interface. But it was written in the year 2000, which is when we first went live. And for the last 20 years, it's had extra code bolted onto it every single week or month, 20 years worth of extra code, nothing ever taken out, all done by different programmers using different styles, everyone in a procedural manner. It's a horrible, horrible mess. And every time you changed it, it broke. You changed something here, something over there broke. You fix that, it breaks 2 more things, and so on and so on. As you can see, when I run the extended check, there's red lights all over the place. So how do I go about changing that? How do I even start? Well, I've got a requirement. I'll start with that. The first step is I'm going to create what's called an island of happiness. It's a model class, model being a class that holds business logic, and it's going to connect to the continent, which is the old monolithic program, hence the bridge on the screen. And like all good object-oriented classes, it communicates via an interface. All public methods of classes should be done by an interface, because that way you can mock them and fake them. And so the very first step is creating an interface, then connecting it to my island of happiness. I'll move on to my business requirement, which was a validation. I had to evaluate some stupid user entries that people were doing on a very common basis. And how would I get that information back from my island of happiness to the main program? Well, I'd log it. You get an error, you log it. I thought, well, I could create my own logging class, or I could use the application log in SAP. But I thought, why invent the wheel? It's already been invented. And on the .abap.org list of open source projects, you can find a project called the ABAP Logger, written by Eric Peterson some years ago now. And it's great. I would advise everyone to have a look at this. It's downloadable via GitHub using ABAP Git. And it's great. It reads what you're passing it dynamically. So you can pass errors from a BDC, errors from a BAPI, a string, system message, whatever. It dynamically works out what it is and puts it in a application log type format. So it's great. Then I create my exception class, which is the best way to handle errors. I always create my own Z exception classes rather than using SAP ones, because I always want to change something. In this case, what I'm changing is I'm putting the logger into it. So an error happens because a validation fails in my model class, my island of happiness. I put that error information into a logging object, pass that into the exception, raise the exception, Bob's your uncle. That way it can get back to the main program. I've now got all the jigsaw puzzle pieces in place to start the test-driven development cycle for real. So this is how I go about it. To start off with, I've got to write in my island of happiness model class, I've got to write some tests. So I need there's a section in classes, specific section where you have test classes and test doubles. So in the first ball here, I'm creating my test class for the model, and I mock up the database access layer and what have you, and anything else I might need. And then, as mentioned earlier, what I need is I need a factory and a so-called injector. A And what's going to happen is that the production code isn't going to create the database access class itself. It's going to get an instance of that database class by calling a factory. In real life, the actual database class will be called. In a test, a fake database class will be called, which gets passed in to the unit test by means of an injector class, which injects test doubles into the factory. So in a test, the factory will come with a double of the database class, which will give you the fake hard-coded values. Then, in the third ball, I've got the so-called setup method. And what that does is run before every single unit test is called. And it creates some fakes, some mock database class, mock customizing class, what's there known as test doubles, and it injects them into the injector. So when the factory is called, a fake object will be used in a test. The next step is I'm going to write my test. Notice I haven't changed any production code yet. I'm still writing the test. And what I'm doing now is a so-called red phase. I write the test using plain English. Given recursive links entered here, for example, what I want this to be is I want it to look like the specification. I want the business analyst to be able to read this and say, oh, yes, that's right. That's exactly like the specification I gave you. So I always try and write ABAP code in plain English if I possibly can. It's not always easy. At least on high levels, you can use method names to try and make it look like English. So first of all, I write the then method, which is evaluating the results. And say, tell it what error message to come up when the test fails, and what result I'm expecting, and what result I actually get. Then I run the test. At this point, of course, it fails. It would fail because I haven't made the change. I haven't even coded the given and when methods. So of course it's going to fail, and that's good. That means we've started the red phase. Then in the given method, I pass in the information that the routine I'm calling is going to be using. In this case, user input. So now I've got a method which passes in user input, and I've got a method which fails when the result is wrong. Good, the red phase is complete. I've got a failing test, so I know as soon as that test, which currently fails, passes, that I've finished. But the final bit is to write the when method. A when method is the one that calls the production code method you're going to be testing. Notice I haven't even written it yet. So I write a method which calls the method to be tested. It's going to give me a syntax error because that method does not exist. So, okay, method doesn't exist, so I'll write it. And the idea is to write the minimum possible code which will get the test to pass. So keep writing code. If you do this in really small chunks, it might not even be a lot, it might just be a few lines. Until such time as your failing test suddenly starts passing. At that point, you've hit the green phase, test-driven development. Test was failing, now it's not great, so it works. You might think, it's over, let's move on. But no. Right. Next cab off the rank is the blue phase, which is often ignored. Now I'm going to sing you a bit of a song here. It's by a Swing Out Sister, and it's got to be perfect. Now, can you see why I became an ABAP programmer and not a pop singer? Maybe. In any event, blue phase is all about, once you've got it working, make it good. Make it as good as it can possibly be. Often you'll just do a dirty hacks just to get the thing working. That's really common. But as someone says, the thing about quick and dirty is dirty stays around far longer than the quick. So you've got to look at your code and say, right, is there a way to do the exact same thing better? This is a so-called refactoring that Lawrence was talking about right at the start of the SAP online track. The first thing is, when running your unit tests, you can do it in what's called coverage mode. And it looks at how many lines of your production code are actually getting tested. As you see at my screen, every line that is tested goes bright green. And lines that aren't being tested go red. As you can also see, it's a bit buggy. It's standard SAP, so one day they might fix it, but it's not perfect. In this case, for example, the end method is bright red, and that's nonsense because it's not an executable statement, so it shouldn't be evaluated at all. And end if really should be green because the if is green. But anyway, leaving nitpicking aside, it's still a very good tool, and it shows you how many lines of your custom code that's in production is actually being tested. And if you find that big chunks in your method aren't, it's because you're not testing a particular branch, for example. Usually you test success case and a failure case. And usually that means you need two tests. One for when things go the happy path, and one for when things go horribly wrong. So try and get as much as you can of the production code under test. If you're building an island, like I'm doing, that's quite easy because it's all new and it's very small. And that's the time to get it all under test. Not wait until you have 500,000 lines of code and then frantically try to get it all under test. The second bit, something people forget to do, even in normal programming, and that is run the extended program check and the code inspector. It's so easy to do. And people, oh, I'm too busy. I'm too busy. And anyway, there are many false positives. Well, I don't know about that. I'd say that a lot of those tests are there for a reason. Now, I've seen people just blithely ignore them and then get into serious trouble with for all entries with a blank table or something, which if they'd run the extended check, it would have told them that no, they had to wait till it was in production and find out the hard way. So running those two as a very first step is great. The third is, some people say it's more soft, but it's actually, I think it's got a hard benefit, and this is the so-called clean code. Because one thing people never stress enough is a program must be easy to maintain. If somebody, including yourself, comes back the program in 6 months' time, it'd be great if they could just look at it and understand what in the world is this program supposed to do. And a lot of these clean code checks are aimed at that, trying to make something more clear, right? So it's easy to understand. The great news is there's 2 projects on GitHub you can download which help you with running automated tests for these sort of clean code type errors. One is the ABAP Open Checks by Lars Havam Peterson, and one is from SAP itself, the so-called Code Pal, which checks a whole bunch of clean code checks adapted from the book by Robert Martin, who came up with the concept of clean code in the first place. And I would advocate that everybody have a look again on GitHub for these projects, download them to the system, and then run them past your code and see what it's got to say. Okay, right, I've finished the blue phase. My code is now absolutely perfect. Great. Now, I've got a great model class. How do I connect it to my main program? I've got to connect the island of happiness to the continent, which is the huge, great, gigantic program I'm changing. So as a first step, I create some global variables to store the model class, the Ethiopian island. Just a few more global variables. It's already got 500,000. So one or two more won't hurt. They certainly won't be lonely. That's no doubt. Then in the initial screen, I put a PPO module, which creates those objects if they're not already instantiated. So the very first time the program runs, the model object is instantiated and it can be used throughout the gigantic program. Then in the DYNPRO screen where I'm changing, I put my validation in typical old-fashioned DYNPRO. It's a DYNPRO program after all. So I've got to work with what I've got. So I do a process after input module to validate whatever it is I'm validating. And within that validation form routine, I do some calls to my model class to do some validations. As mentioned before, it's got a custom exception it raises, which has a logging object inside it. I catch that exception, and then I translate that into the form that the DYNPRO program likes, which is outputting message statements in this case. If I was playing with WebDYNPRO, I would catch the exception and translate that into a format that WebDYNPRO likes. The point is, the model class doesn't communicate with the screen itself because it's purely concerned with business logic. This fits in with a so-called model view controller approach, with the model being the model, shock horror. And in this case, the DYNPRO, which is controller and view, both in one at the same time. Great. Then I do some manual tests. Everything works. That's fantastic. Everything's happy bunny. I can now move on to the next requirement. If I keep doing this over a protracted time period, and make sure that every new change is put into the model class for the business logic. And when I change something, I extract it out of the main program and put the business logic that I'm changing into the model class. As time goes on, the code in the model class gets bigger and bigger. And the code that's important in the main program gets smaller and smaller. In effect, the main program is withering on the vine. And if it withers enough, there's nothing in it, then it would be really easy to swap it out for something more modern, like a UI5 application, for example. That would take many years, admittedly, but it's a journey worth starting on. There is a warning, though, I have to give you. The first time you do this, it's going to look ridiculous. Think about it. I had one validation to do. It really took 4 or 5 lines of code. Yeah, what did I do? I created a model class. I created an interface for that model class. I created some injector class, a factory class, this, that, the other. I did all these tests. I spent ages and ages and ages where I could have written the 5 lines of code in 30 seconds. And yet I spent a day doing all this other nonsense. You tell that to a manager, what are they going to say? They're not going to be happy. Let's put it that way. They're going to say, this is using a sledgehammer to crack a walnut, and it costs 500 million tons of money. So that's ridiculous. And your colleagues, if they don't know what you're doing, they've got no idea about this, I don't know, unit testing or the idea of legacy code or anything. They look at what you've done and think, that's strange. That's ridiculous. And they'll all laugh at you. Oh dear. That's not good, is it? Going a lot faster than I'd anticipated, but I'm not taking questions just yet. I'm going to take them. I'm going to do a summary first of all, and then got some time. I'll take them right at the end, or on the Discord so-called unconference channel at the end of the presentation. Moving on to the summary section of this, I want to talk about the legacy code flywheel. And the flywheel is something that spins faster and faster and faster. In this case, you make your change, or several changes, using the methodology I've just described, and moving the code into the island. So the more changes you make, the more code goes into the island. And the more code that's in the island, the more of the program's under test. So the more of the program won't break when you change things. And the more of the program that won't break means the more changes you can make in the same length of time. And the more changes you make mean the more code is in the island, which means the more changes you can make, and round and round and round you go, faster and faster and faster as time goes by. I always try and end with a call to action. In this case, now I've done it for real and prove to myself, if only me, that it's not just some sort of pipe dream. It is possible to take an incredibly old-fashioned business-critical program and change it in a safe manner. I would advise you to start thinking about your own system. Is there any candidates out there which fall into this category? Maybe you won't pick the most important thing in your company first, like I did, because that's incredibly risky. But I would ask you to think about, is there something, anything, which you change a lot, and every time you change it, it breaks? And is that driving you up the wall? If so, maybe it's time to show it who's boss, right? And this is how, and this methodology I've been talking about today is how to show it who's boss. Secondly, to avoid the problem of everyone laughing at you, before doing anything like this, it's probably best to explain it to your colleagues. Right? So when they look at it, they're not going to get really, really puzzled. And then it is time to begin. Let's start off incredibly slowly. That's the advice I'd give. Is I started off with I said a few validations, really just a few lines of code here or there, just to prove the concept, to prove I'm not making things worse and actually making things better. And once you've got a bit of confidence, you can keep making changes and changes. And as I often said in my talks, if a program is heavily used, there'll be a lot of requests for changes and additions. And in fact, if something's used, you'll probably get a piece of functionality is used, you'll get a request to change it every single year. So after a while, you'll have had requests to change every bit of your program. And if, while changing every bit of the program, you move it into the model class, eventually you'll have the whole thing under test. And that is the aim of the game, because what you want in the end of the day is for you personally to be able to make changes your programs faster with less risk. And 20 minutes early, I've come to the end of my talk. So as the moderator, what's the best way to proceed now?
Hi there, Paul. We do have a couple of questions that were pitched in the live chat.
Okay.
The first one we've got is from Lars Brederman, and he says, "Hey, Paul, I'm very much on the same side when it comes to legible names in code. One thing I wonder about is if there is any data, maybe your own backlog stats or something like that, that shows the benefits of using such naming when developing. Personally, I know that the right names get me to the right domain context, again, much quicker, but I haven't seen any hard data for this."
Well, hard data is very difficult to come by, but there's plenty of anecdotal evidence. Because one thing, if you ask anybody on my team, there's one program, not the one I'm changing, why it's difficult to maintain. It's misleading names. There is, whoever wrote it many years ago would use a form routine starting with get for many different purposes. Sometimes it would read from the database. Sometimes it would change something. Sometimes it would do something completely off the wall, and you had never, ever had any idea what it was. And that meant you spent, you were looking for something. What changes that value? And you had no idea where to start, because the things that changed values didn't start with the word change. The things that retrieved data didn't start with get or retrieve. You had to guess. And changing the names so that they did what the name of the routine actually gave a clue as to what it did, that was really useful. And another example as well, and this is the worst one, and it's a program I hated going in. There was 8 screens, each showing a different sort of data, right? And the guy he did it object orientated, and he used models, and he named them Model 1, Model 2, Model 3, etc. Now that has never been renamed, and that program's a nightmare to go into, because you spend half the time trying to work out, okay, which screen is which model. You can't tell because they're just numbered. So again, no hard evidence, but plenty of anecdotal evidence that naming things correctly and legibly can speed things up a million times.
Cool, thank you, Paul. And we have a few more questions on the live chat. One of the questions from Senthil Kumar Murthy is that, did you make all of these slides sitting in a basement?
If I had to be completely honest, it was in a pub. So I suppose it's gloomy.
Must have had some pretty good beer there.
Indeed.
And the other question was, where did you get all the mice from?
This is very important. And also, when it comes to mice, and this is something I should have mentioned, there's lots of different mice in that presentation, and some of them were holding placards. Right? Every time that you, let's just go and see if I can't find a mouse with a placard. There's one. Right. What that means is that when this is all over, I'm going to make available to anybody who's interested a PDF of this entire presentation. On the very last slide, there's some links to further information. And every time a mouse with a placard was there, that means that on the last slide, which I don't show during the presentation, there's a hyperlink to a blog or some other resource on the internet, just showing more information about whatever it is. And the other mice, which don't have placards, they were there to keep the other mice company. That's my mouse. That's my mouse answer.
Awesome. And we have one more question, and if you do have any, then please get them in now. And that is, all of these efforts need a smooth transition to production. How do you handle that? Any suggestions? And that was from Senthil.
Well,
Smooth move to production. Sorry, apologies.
Smooth what to production?
Move.
Smooth move to production. Yes. Well, the first thing to do is, as I said, was make a really small change. As I said, the first one I ever did in Australia was a 5-line validation. That means I move all my building blocks into production, like the model class, the factories, and what have you. And they're not doing much harm because they're only being called by one tiny routine out of 1,000 form routines in the main program. So even if it all went horribly wrong, it's only breaking one tiny little bit. And even then, if the validation failed, it wasn't going to break the program. So I'm starting off really, really small. And once I've got the building blocks in place, there's less that can go wrong, shall we say, because they're already there and they're already working. I'm just extending something that already exists.
That's fantastic. I think then, Paul, we do not have any other questions. So we've got one final piece of business, and that is the raffle prize.
Mm-hmm.
And I've taken all of the participants in the chat conversation. The winner is Lars Brederman. So congratulations, Lars. You have won yourself a code for OpenChat. And if possible, if you're still in the chat session, we have a form that we need you to complete, just to put in some of the details so that we can get those prizes out to you. Back to you, Paul, for the closing statement. Thank you.
Okay, I just want to recap the main points again, which is transforming or refactoring legacy code is not just an academic theory, it's something that can be done in real life. And I found the benefits are amazing. And I will, once again, reiterate, the end is a call to action. So you ought to try this yourself. Pick a candidate program in your system that gives you grief. Just try it. You'll be happily surprised. As I said, it'll end up with you being able to make more changes with less risk, and that can't be a bad thing. So that's it from me. Cheersy, cheersy.